Okay. Yeah, I guess this is a little warm up for what I should be doing Tuesday to Thursday, right? I have rearranged the furniture. So, I can be a little bit more effective. So yeah, this is. Oh right, I forget that this is the second live that I'm doing. So that I need to do. I need to put the date. whenever I'm doing anything, I might as well put the date on it. So that way, it is, the record reflects, right? So let me put the date. What is today's date? Today is it's June 9 already. It is June 9, 2025. June 9, 2025. Yeah. Believe it or not. So we just start the month and it's soon done already. Yeah. Now, if you notice this is for WhatsApp channel, YouTube channel, Facebook page, Instagram page, TikTok page. For this right here. Yeah. So yeah, that's it. So maybe that's what I'm going to do. I'm going to have to start writing the date so that I remember. Sometimes the time is important, but what was I? Oh, I wonder if I can find that. Yeah, it would be nice if my tablet worked. I'll try unlock it. So I can see. Yeah. I remember that. All right. Base numbers. You have binary and base 10. You have base 8. Yeah, those number systems have the same rules. Alright, let me see if we can get rid of this. See if we can get rid of that. Alright. Now let's go use a few examples then. Just a few of them. Okay, how about this one? How about 20513 in, let's say base 6. No. So everything start from 0 going this way. So this would be so that would be 3 times 6 to the 0, 1 times 6 to the 1, 5 times 6 to the 2. That will be 0, and this would be 6 to the 4. Put them in black and see. So we'll have that to the 4, that to the 3, 2, 1, and 0. Now, you know, I'm going to do the reverse as well. So let's see how best it works if we're going back and forth, right? So all right, let me write them in red over here now, since we don't advertise already. Don't advertise, so I can always get rid of this. Alright, so let's start by writing the first number. Any number raised to the 0 is 1. Then we'll multiply 1 by 6 to get 6. Then 6 to the 2 will be 36. Then we'll have 216. Alright. Now we're going to have, I believe this is going to be 1296. I think so. 1296. So 0, 1, 2, 3, 4. Oh, well, we don't need to go further than this thing. I think we have all the numbers we need there. So that means for this, we have 3 times 1. Then the next one is 1 times 6. Okay, alright, so I think I know what I can do. So 3 times this 1 is 3. 1 times 6 to the 1 is 6. 5 times 6 to the 2. Alright, 36 times 10 is 360. Divide that by 2. So this will be 180. Then, well, this one will be 0. Because 0 times 216. And then now we have 1296 plus 1296. So that will be, alright, 2592. Yeah, 2592, add that to 189. Alright, so in total that's going to be this number right here. Yeah. So now this was base 6. This is base 10. And most of the times we convert whatever base number to base 10 because that is our natural number system. Right? That's the one we're most familiar with. Right? So now that we do that, let's see if I can bring it back to, so if I can go from here to here can I go back from this to that? So let's see if I can do that. So let's remember 2781. So let's try to remember that. Alright, 2781. So we converted from base 6 to 10 a while ago. Alright, so what we did a while ago was I know. Really? God. Yeah. So we went from base 6 to 10, now we're going in reverse now. So the number is 2781. So we can use these numbers over here and help us again, right? But what I would do, I'd write them in a certain order. So I'd write it as 1, then 6, 36, 216, and then 12, 96. No, this is actually trickier because when it's binary, you only have one of each number, right? You only have one of each number. So how would you know how much of each of these numbers you need? You know, how much? How would you know? Because okay, you have 1296. So let's say you decided you know say 1296 is not big enough, and you add that number to itself, and you end up with 2592. Well, you know you can at least subtract that from this. So I think I guess the aim is you're trying to find the highest amount out of it that you can possibly get without passing the number itself. So that's the best I can say. Just like when you're dealing with fractions and that sort of thing. Yeah, you're working with the highest number you can use without passing the maximum itself, right? So we have that. So fine. No. Okay. So my trick for this is, if I add 8 to that number, I'm going to get 2,600, right? If I take 600 from the 781, I get 181. So if I add 181 to 8, I end up with 189. Now, 216 is bigger, so we're not going to use any amount of 216 because 216 bigger than that, right? Okay. So okay, just so that it makes sense, so that we know that the largest amount we need, technically what you're doing is, imagine you're dividing this number by this number, right? The most we can get out of that by dividing this by that is the number 2. Then imagine if you did that again with 189 and you divide it by 36. It's like you're trying to see how many 36s you can get out of the 189, right? But you don't actually literally have to do the division. I mean, that's optional if you want to do that, but you can add the number to itself a couple of times and see what max amount of it gives you that number right there. So how many times you can add 36 to itself until you get close to 189. So okay, let me see now. I can have 36, then 72, 108, 144, and 180. Oh, yeah. So now we're actually seeing it. So the max amount of 36 we need is 1, 2, 3, 4, 5 of them. So we definitely need 5 of them. So we can do this. Right? We definitely need 5. So now we can subtract 180 from that. Right? So you can actually count. And now we'll go on. Because when you look at 6, how many 6s you can get out of the number 9? Only 1. The remainder will be 3. So if you say 9 minus 6, right? 9 minus 6 is going to be 3. So then now, well, obviously you do this. Obviously our last number is 3. Oh, you know what? No, a lie. Guess what? I don't want that in blue. I want that in black. So all the powers of 6, I put them in blue. Right. There we go. Or whatever. Yeah. Alright, so know that that's all we have left. We have to multiply 1 by 3. Right? We have to multiply 1 by the 3. Yeah. So so yeah, if we think about it logically, we're dividing this number by this and say how much of them we can fit into that. Then we pick the largest amount we can get. The largest amount was 2592. We subtract it from that. Then we get 189. We couldn't use 216 because it can't fit into that. Right? So that's why that have a 0. Right? 216 bigger than 189, so we can't use that. Now we try to find how many 36s we could use. Right? So we can fit 5 of them and have it come as close to the 189 as possible. So we use 5 of them, get 180, we subtract it from that. We're left with 9 now. There's only 1 6 we can get out of that, and then we need 3 individual ones. Yeah? And funny enough, it written in order. So you can just write 20513 and that's it. You know, so I guess once you can do this, base 2 binary is the easiest one to do. The easiest one. But I'm going to do another one. And them have the decimal version of these, which, listen man, I mean, it makes sense and it doesn't. Like, I don't know when you would ever need to find a decimal version of like base 6 or base 9 or whatever. It's just madness to me, honestly. It really is. Alright, let's try Lord God, this alright, I'll go to base 9. Base 9 is kind of ridiculous. Base 9, base 7. Yeah. Yeah, man, why would I? And guess what? It makes sense and it don't make sense. Right? Because, okay, alright, I'm gonna do it. I'm gonna do it as ridiculous as it is. As ridiculous as it is to do something that have like the decimal points, I have an idea of what it actually means. So let's say, for example, you've been given some decimal version of, let's say you get something like 0.07154, right? 0.07154, and it's not in base 10, but it's in base, let's say it's in base 8, right? Now here's what I know. I know this over here is at least yeah, sorry, I thought I was gonna sneeze a while ago. This must at least be 8 raised to the 0. Right? That means over here you're gonna have 8 raised to the -1, -2, -3, -4, and -5. Now I can't think of that in any other way. Right? Now here's what that means. It means that you're finding the inverse of what we normally have. So for example, now let me go a step further now. So we have 8 raised to the 1, right? So that means that this is going to be 8. This is going to be... How literal can I get about this? I mean, I can put 1, but it's really 8 divided by 8. Then this becomes 1 over 8, 1 over 64, 1 over 512, 1 over, how that go now? 2 raised to the 3 times 4 is 2 to the 12. 2 to the 12 is... Really? Oh man, them number are too, them number are too massive. So 1 is 2 to the power 15, 1 is 2 to the power 12. 4096. Yeah, right. It's sorry. I kind of fast forward that a while ago. Let me tell you what happened. The number that I remember after, so 2 to the power of 10, if I remember, is 1024. Now 2 raised to the 2 is 4, so if you multiply 1024 by 4, you get 4096. I'm going to try, where is it? Okay, so I have 8. Hold on then. Why the calculator not? Alright, good. So let's show us that now. See? 8 raised to the power of 4 is 4096. Right? So that's why I can comfortably say that. So now, okay, fine. So we multiply this by 8. Oh, yeah. Alright. Yeah, that's a lot of fun. And this is what, 1 over 32, 768. Yeah. yeah. I mean, that seems to be what this should be. Because if we're going with what they've told us about this direction going forward and this direction going over here, right? This have to be the ones place, and then anything else is 1 over 8, 1 over this, 1 over that, blah 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 blah. Right? But yeah, I mean, the only good thing about it is that you know what these are. Because after this, what am I gonna do? I'm not gonna waste my time with this. This, like, what am I gonna do? Multiply 4 by this and then get what? 4 over 32,768. Which, yeah, sure, I can do that. Why not? So I will put 4 over this, because why not? 5 times that, well, this is going to be 5. It not really matter. This is going to be 1 same way. 1 times 1 is 1. This is going to be 7. And then what? These are just, well, 0 times anything that are just 0. Right? So if we were to add up all of this now, I mean, come on. This, I mean, it can do, you know, but this tedious. This is something you give somebody for a project. Like, there's no need to do all of this, because now what you're going to do now is you have to basically find the LCM of all of that, and the LCM of all of that is 32,768. Right? That's really what it is. Right? So let's, I mean, as tedious as that is, if 4,096 times 8 give you that, then you have to multiply 8 by 5. Come on. Oh God. No, this is ridiculous. Alright? So let me see if we can make sense of that. So we already have that, and then the 5 over that is so we have 40 over 32,768. We have 4 over 32,768. So by doing that, we virtually have this and we have this. All right, I could divide so now we have to multiply 1 over this by 64 and 64. So 1 times 64, that means it will be, alright, come on, man. Yeah. Now, man, this is, you're not gonna get this by multiple choice, 1. And yeah, you know, somebody would have to give this as a means for wasted time, because this is, yeah, it's not like it cannot be done. It's not difficult, it's just very tedious. 512 times 7 now. Because, okay, what you're really saying is you have 7 over 64. You want to make it equal to 32,768. But in order to do that, you have to multiply it by 512. So you have to multiply this by 512 and this